All right, this will be exponent and logarithm equations, part 1. In the first example, they just want us to solve the equation for x. I'll just call this example 1. Now, the way they do this in the book is they transform this from a logarithmic equation to an exponential equation. So I'll write that off to the side. If you recall, exponential form, we have b to the power of x equals a, and if you wanted to change that to log form, that would basically be log base b of a equals x. All right, so basically you would take the argument a and put it on the right-hand side of the equal sign. You would take the base of the log and raise that to the exponent x. That's if you want to rewrite this equation in exponential form. Okay, this one right here is exponential form, and this one right here, of course, that's in log form. So that is how they suggest doing this problem. But you can use that if you want, but in my opinion, it can be easy to forget that. So I just like to use the cancellation law. Now, this log has a base of 3, and I am going to make this whole thing the exponent on the number 3. Okay, and since I did it to one side of the equal sign, I need to do that to the other side of the equal sign as well. So 3 to this power equals 3 to the 4th. And now, since the base of this matches the base of the log, they cancel. Okay, if you have a number raised to an exponent, that number is called the base. And the small number on the log is also a base. So if the base is matched, they can cancel. So the 3 and the log base 3, they cancel. And we're just left with the x plus 1. And that equals 3 to the 4th. And now it's simple. Solving for x, the opposite of plus 1 is minus 1. Cancels here. And x is going to equal 3 to the 4th is 3 multiplied 4 times. That's just 81 minus 1, that's 80. All right, pretty simple. All right, see if you can do the same thing here. Since it's log base 2, use the base number of 2, and this will be the exponent. Same here, use the base number of 2, and the 5 will be the exponent. All right, this is base 2 on the log, so this whole thing is going to become the exponent on the number 2. All right, whatever I do on one side of the equal sign, I have to do on the other side. So the 5 is also going to become the exponent on the number 2. Okay, and since the bases match, 2 to the power of log base 2, that cancels, and you're just left with the argument, 3x minus 4. And that equals 2 to the 5th. The opposite of minus 4 is plus 4. All right, I'll do that to both sides. The 4's cancel. Bring down your 3x. Bring down the equal sign. 2 to the 5th is 32. Plus 4, that's 36. All right, here we have x times 3. The opposite of times 3 is divided by 3. The 3's cancel. And x equals 12. All right, once again, they want us to solve for x. Now, in this example, it's actually very easy. The base of the log is 6 on one side of the equal sign, and the base of the log is 6 on the other side. Since the bases of the logs match, we can just remove each one and leave the argument x plus 1 equals 2x. Okay? Now, in case you want me to prove it, it's very simple. Here we have a base of 6. I'm going to take the number 6 and make this the exponent on the number 6. Whatever I do on one side of the equal sign, I'm going to do on the other side of the equal sign as well. All right. So 6 and 6, those are both bases, so those cancel. And we're left with x plus 1. 6 and 6, those both cancel. And we're left with equals 2x. All right, solving for x, I'm just going to do minus x on both sides. The x's cancel. Bring down the 1. 2x minus x equals x. All right, so you can really, if the bases match, you can really just take a shortcut and say the argument equals the argument. All right, please pause and try this one here. So we can see this is log with no base and log with no base. We can really just set 4 equal to x minus 1. But just for your information, when the log has no base, it is automatically base 10. All right, so you can write that in there if you want. And then to prove to you that it works, since the log is base 10, I'm going to make log base 10 of 4 the exponent on the number 10. I want to do that to the other side as well. All right, 10 and log 10 cancel, and we're left with the 4. 10 and log 10 cancel, and we're left with the x minus 1. All right, plus 1 on both sides, and x equals 5. All right, so quick review of the log cancellation properties. If you have a base b, and that is raised to the power of log base b of a number a, the b's cancel, and that just equals a. All right, and if you have log base b of a number b to the x, since the bases match, that is just x. So those are the 2 log cancellation properties you should know. All right, in this section, they want us to solve for x and give solutions accurate to 4 decimal places. All right, so you're going to need a calculator for this section. All right, here we have e to the 2x equals 3. So the base of this number is e, because this is a number that's being raised to an exponent. The number that's being raised to the exponent is the base. So I'm going to apply the log with the same base to both sides. Okay, since this is base e, I am going to take the log base e of both sides of the equal sign. So log base e of e to the 2x, and that's going to equal log base e of 3. Okay, you can use parentheses if you want for the argument, but you don't really have to. And now, log base e, this base of the log is an e, and this base is an e. So log base e of e cancels, and we're just left with the exponent of 2x. Now, on this side of the equal sign, log base e, we said in the beginning, is actually the natural log. So log base e is the same as ln. All right, because that's a special log, so there's special letters for it. It's on the calculator as ln, and that's going to be ln of 3, the natural log of 3. All right, you can use the parentheses, but you don't necessarily need it. And here we have x times 2, the opposite of times 2, is divided by 2, and the 2's cancel. And what I am going to do is use the calculator and round off. Okay, ln of 3 divided by 2, rounded to 4 decimal places. All right, here's my ln, so I'm going to do ln of 3 and close the parentheses, and then divided by 2. Okay, click equals, and they said 4 decimal places, so you want to look at the 5th decimal. If it's less than 5, you round it down. So 0.5493 is 4 decimal places. So this equals 0.5493. Okay, you can leave it like that, or you can put a 0 in front of the decimal. Same thing. But that is the value of x rounded to 2 decimal places. 4. All right, please pause and see if you can do this one here. You're going to do log base 10 on both sides. All right, so 10 is being raised to an exponent, so my base right here is 10. So I'm going to use log base 10. And that's going to be log base 10 of 10 to the power of x plus 1. All right, whatever I do on one side, I want to do on the other side of the equal sign. So log base 10 of the number 9. All right, the base of the log is 10. The base here is 10, so those cancel. And we're just left with the x plus 1, the exponent. And I'm sorry, I forgot to write the 9. Log base 10 of 9. All right, log base 10, when it's base 10, you don't need to write the base. So it's just the log of 9. Okay, and that's what it looks like on your calculator. It will just say log, but that's log base 10. Here we have x plus 1. The opposite of plus 1 is minus 1. I do that to both sides. It cancels here. Bring down your x, bring down your equals. Let's do log of 9 minus 1. All right, hit clear. Here's my log button. I'm going to do log of 9, close the parentheses, and then minus 1. Okay, log of 9 minus 1. See, the log has no base 10, but it's automatically base 10. Click equals. You look at the 5th decimal, 1, 2, 3, 4, 5. The 5th decimal is a 5. If it's 5 or more, you round it up. So it's negative 0.0458. 0.0458. All right, negative 0.0458. And I use these squiggly lines in place of the equal sign because I round it off. If you want to put a 0 in front, you can, but it's the same thing. All right, in this example here, the base here is e, because it's being raised to the exponent of x minus 4. However, we have an additional term here. This e is times 1,000. Okay, so we need to get rid of that first. I made a little bit of a mess there. Yes, but this e is basically times 1,000. Okay, this is 1,000 times e to the power of x minus 4. So let me see if I can just write the parentheses here so you can understand. This e is times 1,000. All right, so we have to get rid of that first. What is the opposite of times 1,000? Well, that's just divided by 1,000. All right, so I'm going to do that to one side. And I'm going to do that to the other side as well. 1,000 divided by 1,000 cancels. And 2,500 divided by 1,000. If this were a repeating decimal, I would just leave it alone. But 2,500 divided by 1,000 is just going to be 2.5. And that is going to equal e to the power of x minus 4. All right, I'm going to leave a little bit of space here. All right, so all I did so far is divide both sides by 1,000. Okay, that's all I did. And now here we see e is raised to this exponent. So since we have a base of e, I am going to take the log base e on both sides of the equal sign. All right, log base e. On the right hand side, log base e and the e, they match, so those cancel. All right, and we're left with the exponent of x minus 4. And on the left-hand side, log base e, we said that's the same as ln. All right, and we're left with ln of 2.5. Now, when you have an e, if you just want to write ln, you can write that, okay? I showed it to you in 2 steps so you understand that log base e is the natural log. But if you want to write a natural log here and here right off the bat, that is perfectly fine. Anyhow, solving for x, the opposite of minus 4 is plus 4. I'm going to do that to both sides. It cancels here. All right, and let's see. Bring down your x and the equal sign. And really, it's going to be rounded off, so I should make the equal sign some squiggly lines instead of the equal sign, because they said round off. All right, we're going to the calculator, so this is going to be a round off. ln of 2.5 plus 4. Okay, let's do this on the calculator. All right, hit clear. Here's my ln, 2.5, close parentheses, and then plus 4. All right, ln of 2.5 plus 4. Hit equals, and look at the 5th decimal. That's a 9. It's 5 or more. You round it up, 4.9163. All right, so this is 4.9163.